Hi, good morning. In time series analysis, so far we have discussed the time series data other than biological data. Now let us move to biological data that may be agriculture or any other production activity, cattle farming, production area like that. In this analysis, we have to find out the trend, growth and magnitude of variability. For trend, already we discussed, we have to use simple regression. Usually we use simple regression, that is y equal to a plus b, bx. But whereas the trend analysis in time series, we have to use a plus bt instead of x. The x is the independent variable, but here the time, the period, here may be the 10 years or 5 years or 20 years, it depends upon the analysis, but the time period is taken as an independent variable, and the production or area or productivity may be the dependent variable. So in the previous video, I have explained how to analyze the trend. Let us move to the other part, the growth rate. There are different formulas applied for finding growth rates. But in case of biological data, there are some other process is followed. Let us see. The researcher Neil Roth in his study recommended that in a biological production process like agriculture, compound growth rate was more appropriate for analyzing the growth rate over period of time using semi-log or exponential function. Semi-log or exponential function. It is also similar to trend analysis or simple regression, but the value of production or productivity or the area is converted into log value, then the same thing is applied. Out of the result, we have the value of the b, that is slope. The slope is taken to find out the common growth rate. We have to apply the formula anti-log of, we have to find the anti-log value for the slope value, that is b minus 1 into 100. In Excel, we use the formula 10 to the power of b value minus 1 into 100. So this formula we are going to apply to find out growth rate. Let us move to the data area. Here the cardamom production in Idiki district. I have taken 10 years data between 2011 and 2020. The production is go on increasing and decreasing. When we read this figure, the trend is growing. It shows growing trend. To apply the trend value, we have to give the trend year. That is, whatever the year, we have to fix 1 to 10. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And 10. And since our calculation should be in exponential or semi-log, we have to find the value of log value. So to find out that value, we apply the formula log open brackets and the value, that is production. So we get 3.89 in case of 2011 production, and we find out the entire year. And let us apply the simple regression with this value, with these two values, this value and this value. So here the log value is a dependent variable and the number of years 1 to 3 up to 10 is independent variable. Let us apply with the help of data analysis in Excel. Already explained how to add the data analysis in the previous video. Please check the previous video. Regression, dependent variable is log value, independent value the year. There is no label. We need only the value. Output range, click. I want the value here. And the semi-log data will be presented in this format. The constant and slope and the error of intercept and slope r square, and finally we find out the compound growth rate. The constant value is given, that is coefficients. This let me copy and intercept error value of constant, error value of slope. Now we have copied, but we get common growth rate. How? So this is the value of b. What is the formula? The formula is ontilog of b minus 1. In Excel, we have to apply the formula 10 to the power b minus 1 into 100. So in the same way, 10 to the power b value. What is b value? That is regression coefficient or slope value, that is taken minus 1 into 100. So the common growth rate for the period of study is 12.34%. And the r square value is here only 0.861. That is also good. Now we have found out the compound growth rate. Let us move to the third part of the analysis, is magnitude of variability. To measure the magnitude of variability in production, coefficient of variation was used. That is used by different experts like Lath Tasting, C and K. Palanichami in the analysis of growth trends of principal crops in Kerala. So coefficient of variation is equal to standard deviation divided by mean into 100. We have to find out the standard deviation and mean. This value should be found out from the actual value. So first for mean, average, and standard deviation by apply function, so this is a standard deviation is mean. Standard deviation divided by mean into 100. This is the formula. So let me take standard deviation divided by mean into 100. So coefficient of variation is 37%. So it is continuously growing. In 2011, it was 7,828, and 2020 it is 17,000. About 10,000 is increased more than 100%. That's why the magnitude of variability is very higher. So now we have found out the semi-log growth trend and magnitude of variability for one set of data. But actually we need to have the more number of data. When we go for analyzing, I have analyzed the Didiki district only. But sometimes we have to analyze for more than 5 or 10. At that time, we have to apply the regression every time, repeatedly. To avoid that, I have created a template. See, now I have taken 10 years data for Idiki district area, Wayanad district area, Palakkad district area, and other district area, and total Kerala. So 1, 2, 3, 4, 5. First work is to find out the log value of every year, and we go for calculation. So when we copy and paste the data in this Excel cell, it will take to the result area. So this template can be